Hello, welcome to the second part of the video series on implementing an epidemic simulator with Python. Before we dive into programming tasks, let's briefly cover the code structure of the project. In the description box for this video, we provide the link to the GitHub page for the simulator. Let's take a look at the three Python scripts: particles.py, SEIR Epidemic Simulator.py, and simulator.py. Let's first proceed with the SEIR Epidemic Simulator.py, which is the main script to run the simulation. In this script, we start by initializing an object of class simulator and an object of class particles. Then, we enter the main loop. The number of iterations is calculated based on the number of days we want to simulate the epidemic. We start each iteration with updating the states, timers, positions, and velocities of particles. Then, we perform the series of epidemic state transitions following the state chart we covered in the previous video. Now, let's take a look at the particles.py. It contains class particles that defines the parameters and behavior of our particles. Basically, an object of class particles holds an array of all particles and stores the information on their 5 parameters, such as position, velocity, age group, epidemic state, and time at current epidemic state. These 5 parameters are randomly initialized. There are also 5 functions. The update records method updates the dictionary, where the keys are the names of the states, and the values are the arrays of particles IDs belonging to each state. The plot method plots the dynamic curves of the epidemic. Next two functions update the velocities and coordinates of our particles. If the velocity of some particles reaches a predefined maximum threshold, then it's reset. It is also reset for dead and severely infected particles. Otherwise, the velocity increases with a random increment. The coordinates are updated based on the distance that a particle passes at its current velocity during one iteration. The last function is getNewCases IDs. It randomly selects contagious particles and extracts the IDs of the healthy particles that were in contact with them. In the main method below, you can find several tests that were provided to verify the completed programming tasks in this script. Let's move on to the simulator.py, which contains class simulator that defines the epidemic parameters and transition functions. Here, we got some general parameters relevant for the whole simulation. For example, simulation length is the number of days we want to run the simulation, which we can pass during the object creation for class simulator. Number of iterations is defined by the simulation length over delta t, which is the time of one iteration. Delta t is essentially the minimum time that a particle can take to pass the distance equal to the disease transmission threshold at maximum allowed velocity. This results in restraining the distance that a particle can pass in one iteration by the disease transmission threshold distance. This way, we do not miss the exposure of susceptible particles to contagious one at each iteration. Please take your time to get acquainted with these parameters in more detail. In this script, there are also 5 state transition functions. The first one is susceptible to exposed, where we make first transition based on the provided IDs of the particles that were in contact with the contagious ones. The exposed to infected and infected to recovered methods are based on the rules we described in our previous video. In the infected to severely infected function, we randomly update infected particles to severely infected based on the predefined rate, which was referred as beta in our previous video. Last but not the least is severe infected to dead or recovered method. Here, severely infected particles can either become deceased based on the predefined mortality rate or recover. The main method below contains tests to verify implementation of programming tasks. Before moving on to the next video, where we will go over the 4 programming tasks, we strongly recommend to review provided code together with the rules for the state transitions introduced in the previous video. Stay tuned.